Hey everyone, welcome back to another video, and this is another recording video by pynetlabs where we're going to talk about how CI/CD pipelines really work. I'm also going to show a lab demonstration to you to help you understand how do these CI/CD pipelines really function, and how can we really use it for the network automation perspective. You see, when Cisco certifications were introduced, then at the professional level of dev core certifications, there used to be a topic. There currently also is a topic for infrastructure as code or for workflow automation. And the workflow automation is more about, I would say, creating an entire full-fledged workflow to make your complete deployment from building to testing and to deploying the entire configuration to your network devices in an automated workflow without any manual intervention. So in this particular video, we're going to understand what exactly is CI/CD pipeline, how does it function, and then we're going to talk about a lab implementation about it. So if I talk about this scenario over here.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Yeah, so if I talk about a scenario here, you can see that this is a common pipeline process that you can see here, right? Where we have the development PC, and this particular development PC is gonna make some configuration changes locally, like maybe writing down a Python script which actually communicates with your network devices, and then it performs some configuration changes on that particular devices. So let's say on this development PC you have few scripts. For example, we have ospf.py, we have maybe vlan.py, or any other script, right? Now, whenever I'm going to write that particular script as a developer, I will actually make sure that I push that particular, I locally commit that, and then I'm actually gonna build an entire workflow to first create that development, then test whether that particular development is working fine or not. And if it is working fine, then only deploy it on my production environment. I am not going to directly create my ospf.py script and then directly execute configuration on my devices. Like I may be having router 1, router 2, router 3, and so on. That's not how it works. Okay, so usually whenever engineers work in the environment, think of it this way, that you are the developer. Let's say this is the developer number 1, that's the developer number 2 in the organization, and maybe that's developer number 3 in the organization, right? Now all these 3 developers, they're sitting somewhere in the office and they're connected using the ISP with the internet, and maybe remotely somewhere else you have your network infrastructure, right? And in that particular infrastructure you somehow have connectivity with the production devices. Maybe you have router 1, router 2, router 3, and then you also might be having a jump server, right? So what usually engineers do, then these engineers, maybe they are sitting somewhere in Dubai, but your network infrastructure is hosted in maybe Hyderabad in India, right? So the people sitting in Dubai, they would actually access this jump server by using some remote access VPN or any other medium that's there, and then they will actually copy the script that they have locally created. For example, this particular developer have created ospf.py, this developer have created vlan.py, maybe this developer have created bgp.py. So all these scripts, they need to be copied over here on the jump server, because the developer machines, they do not have reachability directly to the network infrastructure, right? So you copy those scripts on the jump server, and then when you execute the script on the jump server, the configuration gets applied to these devices, which means you cannot directly do that. You manually have to trigger the execution of the scripts by somehow connecting with that jump server. Here, when we work with CI/CD pipeline, we are automating this process. And to automate this process, we actually make use of a version control system and a cloud hosted provider. For example, we globally have the reachability of GitLab as one of the provider for this service, right? Which provides you CI/CD pipeline capabilities. Now, let's say what you're going to do is whatever local development you did, right, for OSPF, for VLAN, for BGP, you converted that entire development into a Git repo, and then you uploaded that repository on the GitLab, right? Maybe you can also have your private GitLab server hosted for your organization, like myorganization.gitlab.com, or you may use the globally publicly available GitLab servers. So let's say my scripts now, which we were talking about, ospf.py, vlan.py, bgp.py, right? All these scripts are now sitting in a repository available on gitlab.com. And then I am actually gonna register my jump server in this GitLab server, right? Something called as a runner machine. Now, when I register this jump server in the GitLab server, right, as a runner machine, then whatever public repository I uploaded, where I had ospf.py, where I had vlan.py, where I had bgp.py available, I will actually write down a cicd pipeline file, which will contain the instructions of how this particular file needs to be executed, right? And whenever that pipeline will be triggered, the GitLab will actually communicate and send instructions to execute these files to the jump server, and then jump server will automatically execute those files, and eventually it will cause configuration change on this device. So you are automating this build, test, and deployment, right? Maybe let's say you also have a production environment, like this is your prod network, okay? And then you also have your test network somewhere, right? You have similar devices virtually simulated like R1, R2, R3, but this is a test network. Now, what you want is the script that you created, right? ospf.py. That first needs to be given to the GitLab. GitLab should execute that script first on the test network. If it passes, then only it should be executed on the production environment, right? So this is called as building a strong testing environment, that you only push configuration to your production environment if the tests passes, right? So that's one of the DevOps lifecycle, DevOps practice that we follow while working with CI/CD pipelines, right? So when you actually do the build, in the build process, you actually put up your source code. You actually make sure that the jump server gets to download all the dependencies that are required for that particular project, or that for that particular pipeline. And after that, the execution on the test and the deployment will start, right? This is how usually a pipeline process looks like. And you can also see that when you go to, after the build, when you go to test environment, then you can have your unit test, you can have your integration test, and once they are passed, then the deployment can happen maybe on your staging environment or on your production environment, so on, right? And when the pipeline runs, it basically goes through all this process of build, test, and then deployment to the production, right? That's a generic CI/CD pipeline, how it looks like. And when you do it in a tool like GitLab, then this is how all your stages can look like. So you can see there is a stage called build, there is a stage called test, there is a stage called staging, there is a stage called production, and these are the jobs. So in build stage, a job called build is being executed, right? In test stage, a job called integration test and unit test, both of these jobs are being executed. Maybe you have created some sort of script for each of this job. The build actually takes care of installing everything, validating whether your syntaxes are correct or not for your script and all. The test may be some Python script that can actually execute and check whether all your functional and programmable outputs are correct or not. The staging can take care of making the configuration changes on the test network. Packaging Docker maybe is kind of a Docker file which actually converts your application to a Docker image, and then you would finally deploy that particular environment into production. So CI/CD pipelines are not just used for network automation. They're used almost in every domain that's available. We are gonna see how we can actually build a CI/CD pipeline that can actually take care of making configuration changes on your production environment, and then first on your testing environment, and then finally deploy the config change on the production environment, right? So I'm gonna share another screen of mine, and I will help you understand how that really works. Yeah, so you can see here, that's my Ubuntu machine. Let me just log into that. I already have created an environment, and this is my EVNG, where I have created about 2 topologies. I mean, this is just a single topology. There are a couple of devices as test lab, couple of other devices as production lab, right? What I want is I simply want to configure a loopback interface on these devices and test whether these loopback interfaces are functioning well or not. Okay, and for that I have created an entire workflow automation repository. So if I jump to my Visual Studio Code, this is basically a repository that I have called cicd test, in which we have few scripts, right? Under the script directory, we have build.config.py, we have test connectivity.py, and we have deploy.py. So what does build.config.py do? Build.config.py actually combines the Jinja template which we have created, and it creates a configuration for providing the host name on the router, as well as configuring kind of OSPF on that particular router. Okay, and making that making the loopback network which we are creating. So you can see here we are creating a loopback interface also called interface loopback 0, and then the IP address, what should be the host name, what should be the IP address for the loopback interface. That's something which we have defined in these prod_inventory.yaml and test_inventory.yaml file. So on the test network, the first 2 routers, we will be naming the first router as R1 test. Will be the IP address, the management IP address for that R1 test is 10.255.1.91, and the loopback that we will be configuring on that particular router is 1111. Similarly, on the for the second test router, we'll be naming it as R2 test. That's the management IP address of that router, and the loopback we will be creating on that router would be 2.2.2.2. And the same details are there in the prod inventory, but that's for the other 2 devices, right? So the management IPs of my R1 prod is 10.255.1.101. We'll create again a loopback of 1111 on that, and then the host name is R2 prod for the second router in the prod box, and the management IP address is 10.255.1.102, and the loopback we'll be creating is 2222. So the Jinja template is actually gonna render a configuration for each of the device, and you can see we also have a output directory which currently do not have any particular file. But when we run our script called build_config.py, so we will integrate the YAML file for test and prod with the J2 file, which will actually create a unique CLI configuration for all 4 devices that we have in the topology, right? And then the test_connectivity script, right? This particular script actually executes some configuration changes, right, on the test devices. And your deploy.py, that particular script is actually gonna make configuration changes on the other 2 devices. You can see the inventory file that we're using for this is prod inventory.yaml, and under the test connectivity, the inventory file we are using here is test inventory.yaml. So the test connectivity will make changes on the test devices, and the deploy.py will actually make changes on the prod devices. And then we have created a GitLab -ci.yaml file, this is how your pipeline file really looks like. And in the pipeline, you can see we have defined few stages. We have a stage called build, we have a stage called test, and we have another stage called deploy. Now, before this particular script executes, we need to make sure that the runner machine, the jump host who actually has connectivity with the device, has all the libraries installed. So we have listed all the libraries that we need to be installed in a file called requirements.txt, right? netmiko, jinja2, pyyaml. And when the GitLab.ci, when the pipeline file will execute, then all the libraries listed in that particular requirement.txt file will be installed. Then we will execute a Python script, which is to create configuration, render the configuration for test device and prod device, and store it in our directory called output. So you will actually see like r1 test.config, r2 test.config, r1 test. R1 prod.config, r2 prod.config, which will contain like individual commands that needs to be executed on those devices, right? So that's our job called build_config, and that job is part of the build stage, The second job is test config. So in this particular stage, we are gonna run our test_connectivity.py script, which will first deploy the configuration on the test devices, the first two devices that we have in the topology, this one. And then if that particular stage passes, then only you can see the third stage will run, which is to execute the deploy.py script, right? And when that particular script gets executed, you will actually have the production devices configured with the supposed loopback interface and supposed loopback details, right? That's what our job is all about. So to test this, we are first of all going to convert our repository into a Git repo. Then we are going to push this repository on my GitLab account. You can see I already have signed in to my GitLab account here, right? There are a few projects which I've been working with, and we will push our project that we have created to the GitLab, and then we will register my same Ubuntu machine as the runner machine. Since we are in a lab environment, I'm not using a dedicated runner machine for this job. I'm going to use the same development machine as my runner machine, but in production environment, this is definitely going to be different. You will have a dedicated development machine and you'll have a dedicated runner machine. Here it's same for us. So we will register this Ubuntu box as a GitLab runner for that project, and then we will see how that pipeline gets executed. And as soon as the pipeline gets executed, we shall see upon success of the pipeline, the configuration should be done on the devices. Currently, if you see currently if I go to my topology and take like R1 test 1 access, you can see the device is powered on. So I guess R1, currently the naming is R2, then R3, and then R4. You can, I think R1's configuration was not saved. That's why the management IP address and something that I have to ensure here, which will just take a couple of minutes for me. But you can see on R2, we already have our management IP address set up. So there is 10.255.1.92. There is no loopback interface on this. On R3, you can see there is a management IP address of 10.255.1.101, and R4 we have management IP address of 10.255.1.102. Okay, and if I try to SSH to these devices, like first of all check whether the reachability of your test device is up or not, right? So you're going to check that first. There you go. Whether your production device's reachability is up or not. There you go. And your last device, that's also up. right? And when I try to SSH to them by using admin and 10 to 55 1.92, oh sorry, 1.92, you can see the password prompt comes up and we should be able to log in into the device. That's R2. When I test for 101, there you go, password Cisco, and we are in. That's R3. And then when I test it for the fourth device, that's R4 currently, right? I guess R1's configuration is something that we need to take care of because the config was erased. So config T, the basic configuration which I did on this device is simply naming them to R1, R2, R3, R4. R1 and R2 are going to be our test devices. R3 and R4 are going to be our prod devices. So I'm going to say hostname R1, configure the management IP address 10 to 55 1.101 along with the subnet mask. Description will be connected to management, no shutdown and take an exit. That's how you power on your management interface. I'm gonna say configure a domain name first, saying IP domain name abc.com, crypto key generate RSA modulus 1024. That's gonna create an RSA key with the length of 1024, and then I'll say IP SSH version 2. Username admin, privilege 15, password we will configure Cisco for the local password, line VTY 0 space 4. After that, login local, transport, input, all. And that's the basic configuration which you require. So you can validate whether you can now communicate to 101. I think first I'll just ping to that so that the ARP resolution happens. And there. And then let's try to SSH. This sometimes takes some time. Okay. It says duplicate IP. Okay, let me do one thing. Yeah, I think we're good there. The second device is using, oh, okay, this is our test device, right? So we should actually use 10 to 55 1.91 as the IP, not 101. 101 is for prod. Now it should go. Let's go back to the terminal. There you go, SSH admin at the rate 10 to 55 101. That's working fine for the R3, perfect. And then when I say SSH to the 91, I think first I'll have to do the ping, perfect. And then SSH to 91. Okay, the RSA keys needs to be updated here. So I can copy that and paste the command and now try to SSH. And then say yes to the fingerprint, password is gonna be Cisco, and we're in. So all four devices are now working fine. And now it's time to actually convert this code into a Git repository, push it to my GitLab. And because we already have the pipeline file defined, it is gonna trigger a pipeline which will execute these jobs: build config, test config, deploy config, right? So the command that we can use to convert this into a Git repo is git init. You can see that it says initialize the Git repository. All of these are files which it is not tracking currently. So we will say git add period, which is going to start which is going to allow Git to start tracking all these files. Then we will do our initial commit by saying git commit -m. I will put up a message like this is my initial commit, right? And now all the changes are locally committed. Then we need to push this particular project to our GitLab account. So I'm gonna say git push, and for the first time we will use a flag called set upstream using the address of our repository, which is gonna be https://gitlab.com/ my user ID of my account, which is Abhijit Bakle 96 / I will name this particular project as cicd _test.git space, the branch name is going to be master for me, and hit enter. It's going to use the username of my account, the password for my account, and the project should be pushed. There you go. It's done. Now when I go to my Git account, in the UI there, you can see all the projects. If I just refresh this particular project, I mean this web page, you will see the newest project there, cicd test, you see, and quickly a pipeline have been triggered. So whenever you have the cicd file available, it is going to trigger the pipeline execution. How do you check the pipeline? You can open that particular project, right? cicd test. You can see all the files are there, and under this is your projects menu. In that project menu, you can go to build, you can go to pipelines, and here you will see all the pipelines, and you can see one pipeline was automatically triggered, right? But it is failed. And what's the reason of failure? If I open that pipeline, it's going to show you that pipeline was failed, right? These are the three stages. You see build, test, deploy. In build, you have failed job. What's the reason for failure? When I open that job, it's going to tell you that the reason for failure is this, right? So this is the terminal output. And what's happening basically is by default, so there are different type of runner machines available. Some runner machines are available and hosted on GitLab servers, which are publicly available to anyone. You can see here that which runner actually picked up your job. So it is picked up by one of the SaaS service runner available, which is green.sas linux small amd64.runners.manager.gitlab. So this runner machine is publicly hosted on GitLab server. That runner machine do not have reachability to the devices which we have in our event, right? So we have to register our own runner, right? And disable these instance runners which are available publicly for everyone. How do you do that? So you can actually go to the project settings, and then under CI/CD, we're going to go to runners, and in runners, you can see there are so many runners which I have used previously. These are called as project runners. And if I scroll down, you also have group runners. Currently, we don't have them. And then you see instance runners. These runners are available to all groups and projects. Each CI/CD job runs on a separate isolated virtual machine. So these are runners which are publicly available by GitLab, right? I'm going to disable them since these runners do not have reachability to our Eve devices. And when I disable them, I'm going to register a new runner, right? Here I'm going to say create a project runner. And in the project runner, we don't need to use any tags for now. So I'll just say run untag job, nothing in the optional config. Maximum job type, you can see it must be minimum of 600 seconds. So I'm going to say 600 and say create a runner. Now, when I create this runner for the project, it's going to give me a token. There you can see it says copy and paste the following command into your command line to register the runner. So on our runner machine, we have to run this command so that our runner machine makes contact with GitLab's project and it can start receiving instructions from GitLab to execute some script. So I copy that command and simply paste it, right? GitLab runner register, the URL is this, the token is this. Hit enter. It's gonna ask you what is the GitLab instance URL. So we know it's this. Hit enter. What do you want the name of the runner machine to be? I'm fine with the default suggested one. And then what's the executor? So on your runner machine, which applications should execute the instructions, right? We want all our scripts to be executed on the shell, right? So I will type shell there and hit enter. And when I run that, it says runner registration successful, right? You can also try saying GitLab runner run to manually start executing the runner job. And there you see executing initial. As soon as you do that, your runner machine will contact to the GitLab. You see, you have registered a new runner. And then when I say view runners, it's gonna show you which all are the runners available for your project. There you see one online runner found. When I see the details of that runner, you can see that's a runner, right? 27 seconds ago it contacted. And now we can actually run our pipeline. So pipelines can be scheduled, pipeline can be manually executed, right? Pipelines can be automatically executed whenever you make any configuration change in your repository or add any, push any new change. Since one of our pipeline is failed, now I'm gonna say new pipeline. So I'll click on new pipeline, which is actually gonna run a pipeline manually. And there, run new pipeline, no variables, no inputs right now. I will simply say new pipeline, and it's gonna trigger that particular pipeline. And there, it says pipeline is in pending state. Now this is where the GitLab starts making communication with the runner machine, and it asks the runner machine to execute your jobs. So under build config, according to our code, under build config, these two Python scripts should be executed, right? Which is to render the configuration for your test as well as prod devices. And if I open that job, currently it says that the job has not started. The job is in pending state and waiting to be picked up by them. Now in lab environment, sometimes the runner machine do not pick up the job automatically. But in production environment, when you deploy runner machine as a server, it does that. But we can force our runner machine to check if there are any pending jobs by using this command called GitLab runner run. And you see, it added the job to the processing list. And there you can see now, there, it has picked up the job. And there, I think it says that this was the error. You can also see what exactly is the error that has been found in the directory. I mean, in your code repository, and you can see it says that there is no such file or directory called output/r1.test, because in our project repository, to store the rendered files, it did not find any output.txt environment, right? So you can also manually make changes to this particular repository to add a new directory. There I will simply say new directory, and I'm going to name it as output. Okay, because that directory is required, even though we have it as part of our repository, but that was empty, so the repository was not actually pushed. So I'm going to say create this particular empty repository called output, and now you can see that there is an empty file there, empty folder called output. And what we will do, we'll go back to the build, we'll go back to the pipelines, and then we're gonna rerun the job that was failed. So I'm gonna go there. You see, automatically, as soon as we made changes, another job was triggered. You can see the stage 1 now has passed, but stage 2 failed. Let's see why. I will open that repository, that pipeline. You can see the first stage now passed, second stage says failed. Let's see that. This is part of when you develop your pipeline for the first time. Here it says that missing the config file called output/r1-test.cfg. Now why that happened, let's check that. Because So when I go to my project, when the first stage is completed, we should end up having some file into this folder, but that r1-test is not available. And if I go and check my pipeline definition, okay, and in build config, I'm just checking, so that's correct. Where the rendered configuration should be stored in output / whatever the name of that particular file whatever the name of the device .cfg should be. So we should end up having that particular file there. Let me check the exact error. So when I go to build pipelines, so since the test connectivity.py has been executed, first it executed the pip install -r, which means it installed the dependencies. Then it started executing test connectivity.py. Oh, that's weird, because as part of the build config, these two files also should be executed, but they were not executed. Okay guys, you can see our second job was now failing, and when I open that, the first job is passing fine, but the second job failed. And the second job is failed because it says missing config file. So it's not able to find the config file. And if I go all the way to the top, okay, here you can see it is, whenever this job is triggered, it is removing all the files that were created as part of the first job. So what I've did, because whenever the pipeline executes, each stage actually creates a separate file structure. So the files that were created in the first stage will not be accessible by the second stage. And the way to solve this is to use artifacts, right? Artifacts is basically a local file storage for your pipelines. So I've updated my pipeline to actually, you can see here, to actually store the outcome of this particular script into an artifact directory called output. And this file will automatically expire in 1 hour. And then we're going to pass this particular folder to the next job. So I've updated this particular change. I've pushed that particular change also, right, in the background. And now we will try to run this particular pipeline. And I will simply say new pipeline. And there you go. The job is running. First job is running, which is build configs. That's passed. Now it's going to the second job. Go to the pipelines at the background. Check the second job is running. And you can also see in the terminal outcome that you can see that it's adding jobs in the background. And there you can see the second job is also executed, which is to test the configuration on the prod device, on the test device. And then the third job is to actually deploy the config on the prod devices. So second job pushes the config on test 1, test 2, and the third job pushes it on prod 1, prod 2. And there you can see all 3 jobs are done, which means your pipeline is passed. And now if I go to the fourth device, you will actually find that the name of the device have been renamed to R2 prod. You should see a loopback interface created. There you go, right? So that's how you can actually automate an entire workflow. And no matter how complex your workflow is, you can automate the execution of multiple scripts in a staged manner, right, with the help of pipelines. I hope you enjoyed the content of this video, and thank you so much for watching this, and I hope this helps you for your DevNet preparations. If you want to learn more about these automation skills, do sign up for one of our automation trainings, and it will definitely help you to upskill your career. Thank you so much. See you in the next one.